What is the area of the inscribed square in a quarter circle? We use Pythagoras' theorem, trigonometric identity, basic arithmetic and algebraic operations to solve this question. Label points A, B, C and D. Locate the center of the quarter circle O. Join line OB, which equals the radius, R of the quarter circle. From triangle DOA, line OA equals R-6, and line OD equals R-8. By Pythagoras' theorem, the square of line AD equals the sum of the square of line OA and the square of line OD, which equals to the sum of the square of R-8 and the square of R-6. The result is equals to 2 times the square of R-28 times R plus 100. Take the square root of the equation. This implies that line AD equals the square root of 2 times the square of R-28 times R plus 100. Hence, the square of line AD equals the square of line AB. It is because the side lengths of a square are equal. Let center angle AB equals to theta. From triangle AOB, using cosine rule. The square of line OB equals the sum of the square of line OA and the square of line A, B minus 2 times the product of line O, A and line A, B times cosine 90 degrees plus theta. Substitute values. We have that the square of R equals the sum of the square of R-8 and 2 times the square of R-28 times R plus 100 plus 2 times, in bracket, R-8 times the square root of 2 times the square of R-28 times R plus 100 times sine theta. Since cosine 90 degrees plus theta equals negative sine theta. From triangle DO, a sine theta equals line OD divided by line AD, which equals R-6, divided by the square root of 2 times the square of R-28 times R plus 100. Substitute into the square of equation, above. This follows that the square of R equals to the expression in the right-hand side, as shown on the screen. Expand brackets and simplify. This implies that the square of R equals 3 times the square of R minus 44 times R plus 164 plus, in bracket, 2 times, in bracket, R minus 8, bracket close, times, in bracket, R minus 6, bracket close. Simplify and combine like terms in one side of the equation. We have that 4 times the square of R minus 72 times R plus 260 equals to 0. Factorize. We have that 4 times the product of R minus 13 times R minus 5 equals to 0. Equate each factor to 0 and solve for R. Hence, R equals 13 or 5. R is not equals to 5 units. From the given figure, r is greater than 8, which is greater than 6. Therefore, r equals to 13 units. Substitute r equals 13 units into equation 1. The square of line AD equals 2 times the square of 13 minus 28 times 13 plus 100, which equals to 74 square units. Since the square of line AD equals the area of the inscribed square, therefore, the required area of the inscribed square is 74 square units.